Blake?
Okay, so right now we're doing factoring trinomials.
Okay. Trinomials? Okay. The
Yeah.
other thing you always want to have in front of you when we're doing a session is a calculator.
Okay.
Whatever calculator you use in school, that's the best one. What kind of calculator do you have?
Graphing calculator.
Okay. Is it a TI-84 or something like that, or is it an Inspire?
Yeah. TI-84.
Oh. All right. So it sounds like you can read some of them if you're factoring polynomials. Why don't you give me the polynomial? We'll look at
All right.
it. Read it?
All right. So first one's b squared plus 8b plus 7.
And you're supposed to factor that?
It's 8b, not a.
I was going to say, that's going to be hard to factor. Okay. All right. There is nothing more important in algebra other than being able to solve equations than factoring. I'll just tell you that right now. Schools tend to teach a lot of different methods for factoring. I kind of have my own. I don't know what they've taught you. I presume they've taught you FOIL for multiplying two terms.
Yep.
Okay. So what factoring is the opposite of FOIL. In other words, if we go down here and we say, what is x plus 2 times x minus 3? Multiply those two for me.
Okay.
Just read the next line.
All right. So it'd be x squared minus 6, and then it would be.
Hold on. Remember what FOIL is. FOIL is that. That's where you get the x squared. And then the outside, the O of FOIL, is that. So that's minus 3x. And then the inside, the I of FOIL, is plus 2x. And then it's the last term, the L. Remember what we're doing, FOIL. The last term is minus 6. Okay. Now, what always happens in this is you always combine the two middle terms. So we end up with this. Okay. So knowing that has a lot to do with how you factor. Notice that when I multiplied those two terms together, the x squared came only from that times that. And the negative 6 came only from that times that. So the first term and the last term comes from the F and the L of FOIL. And that's going to help us factor a lot. Okay. Now, I'll leave it in B. It doesn't really matter what letter you use. In other words, in the lower right, I used X as the variable. And in your problem, they're using B as the variable. It's fine. So let's talk about how we're going to factor this. I, first of all, separate factoring into easy and hard. This is easy. The reason it's easy is because the squared term has a 1 as a coefficient in front of it. B squared has a 1 coefficient. If it's a 2 or a 3 or a 4 or some number other than 1, it makes for a difficult factoring problem. But if it's a 1, like this is, then it's really a really easy factoring problem. And I just want to teach you my 3-step method. Unless you can factor that already. I don't want to start from the beginning if you don't need me to. Can you factor that?
Yeah, I think so.
Okay, what is it?
Would it be B plus 7 and then B plus 1?
Good. Let me give you some others. Factor that.
That would be X plus 5 and then X, no, wouldn't it be, yeah, X
There's the problem. Okay.
X minus 5, right?
Minus. Let's go through my steps because my steps are pretty good. The very first step I'm going to do is separate the x's. That's step 1.
Right.
The second step is the one most students want to ignore. But the second step is where you determine both signs. How do I figure out what both signs have to be? In other words, the way you did it in your head is you were trying to determine that factor, and then you were trying to determine that factor. That's not really the best way to do it. The best way to do it is work them both in at the same time. So what do both signs have to be? What does this plus sign tell you right there?
That it has to be that.
They have to be the same.
Yeah.
They can't be plus minus or minus plus because that would be a negative 25 if they were. Remember when we FOILed it, this number comes from that last two numbers that are multiplied together. So this plus sign tells us that they're either the same, which means plus plus, or minus minus. Now how do you tell which they are? Is it plus plus or minus minus?
Minus minus.
Yeah, you look to the middle term. In other words, because that's a minus, it has to be minus minus. And that is the second step. Now the third step is relatively easy. We're looking for factors of 25 that do what?
That add to 10, negative 10.
Add because that is a plus sign. So they need to add to 10. So that's going to be 5 and 5. 5 and 5 add to 10. That's how you factor that problem. Okay? Let me give you another one. Slightly harder. First one had only 3 steps to it. This has a 4th step. But the first two, actually the first 3 are the same. What's the first step?
Alright, so X, you want me to go through the steps or just solve it?
I'd like you to, because I think that's the best way to learn how to factor.
Alright, so separate them and then.
Second step, determine both signs. What do both signs have to be?
They both have to be
Opposite or the same?
don't have to be opposite?
Yeah, you cannot produce a minus 12 unless one is a plus and one is a minus.
Right.
Now, it doesn't matter where I put the plus and where I put the minus. I could put the minus first and the plus second. In this problem, it doesn't make any difference. Okay? Okay, the third step is the same. I'm looking and verbalize it. What am I looking for? Factors of 12 that do what?
I add to 1.
Nah, that's a subtraction sign now.
Or that subtract to 1.
To subtract to 1. So whatever the sign is, they either need to add to that coefficient or they need to subtract that coefficient. Well, let's look at the factors of 12. Which factors subtract to 1?
3 and 4.
Okay. Now that we've found our numbers, but it matters now whether the 3 goes on the left and the 4 goes on the right or vice versa. So there is a fourth step here. And that fourth step is you take the larger factor, the 4, and you put it with the sign of the middle term. So the 4 goes with the negative sign. 3 goes there. That's it. Okay? So these simple factoring problems, simple because that's a 1, all come down to this, these 3 or 4 steps. And you can do every single one of them with those 3 or 4 steps. If you cannot do them with those 3 or 4 steps, then you go to the quadratic formula. Okay?
Okay.
Now, let's talk about a slightly harder one. Hold on. Now, this is harder because that's not a 1.
Right.
Okay? So there are really 2 categories of factoring quadratics, and that's the easy ones and the hard ones. Now, in practicality, when you take a test, 9 out of 10 are going to be the easy ones. When you take your SAT test, when you take your ACT test, 9 out of 10 will be the easy ones. So if you can master the easy ones, you've got yourself an A right there. Okay?
Mm-hmm.
I will show you how to do the harder ones, although I'm not sure we'll get to it today, because I want to cover the easy ones. I want to make sure you have a mastery over the easy ones. Now, I said this was not an easy one, but there's something you can do to this to make it an easy one. What's the first step here?
To find the greatest common factor.
Right. What is it?
2.
Okay. So I'm going to factor out a 2. What does that leave me?
X squared minus 7x plus 10.
Yeah. What I recommend all students do at this point is check your work immediately. In other words, multiply that together. Did I get this? Multiply the second term. Did I get that? Multiply the third term. Did I get that? It's better to check your work as you go rather than waiting till the end. Because if you have 12 steps in a problem and you get to the end and you don't get the right answer, you're going to have no idea where you went wrong and you have to start all over again. But if you check along the way, it's very helpful. Now, notice what that did. That gave me a first level quadratic. So I still need the 2. How does that first level quadratic factor again?
Would it be x, and then it would be, it would have to be,
Both signs?
both sides would be a plus sign.
No. Remember, look to the middle term. Both signs are the same.
Minus sign.
Minus sign, exactly. And then what 2 factors of 10 add to the number 7?
5 and 2.
Okay. So what we've done is taken this, what looked like a higher degree quadratic, and merely by factoring out a greatest common factor, I reduced it to a simple quadratic that you can always solve using my 3 or 4 step method. Okay. Now, go ahead and give me another problem, one of yours.
Here's
You can
one,
make
I
a
guess.
harder one if you want.
Alright, let's do...
You're familiar with difference of perfect squares?
Maybe? I don't know.
Let's cover that. I feel like it's pretty important to go in a certain priority. Now, notice the difference in this quadratic. This is still a quadratic, but it's missing an x term. In other words, it's got the x squared term and it's got the number, but it doesn't have an x term. So this is not going to factor like we just factored the others. However, there's a formula that says when you have the difference of perfect squares, it always factors into a minus b times a plus b. So using that, how would this factor?
It would be x on both, and then it would be...
This time I want you to do the left term all alone. What's the left term? A minus b?
Okay.
It's x minus 5. And now the right term is merely the conjugate of that. You know what conjugate means?
No.
The same two things, only a different sign. In other words, when you are factoring difference of perfect squares, you do this first. Once you get that, this is automatic. And the way you get this first term is you take the square root of that and you take the square root of that. It's that simple.
Okay.
Okay? So, here's the order that you want to do factoring. You always want to look for greatest common factor first. Then you want to check for difference of perfect squares second. And then normally if neither one of those applies, you have a factoring where you have an x squared term, you have an x term, and you have a number. And you proceed into factoring it. All right, what else do you have as in terms of problems?
5x squared minus 30x plus 40.
Plus 40?
Yeah.
Okay. So let's look at our priority list here. Can we take a greatest common factor out of that?
Yes.
Okay, read me the next line.
5 parentheses x squared minus 6x plus 8.
Perfect. Notice we now have a simple quadratic to factor. Okay? Can't get rid of the 5, but we're going to bring it along for the ride. Factor that quadratic in the way I taught you.
It would be x, and then the signs would have to be, it would have to be a minus and a plus sign.
Hold on. What does that tell you? The signs have to be
The same.
the same. So it can't be minus and plus.
It would both be minus?
Yeah, you look to the middle term. In other words, you know it's either minus, minus, or plus, plus. And the middle term tells you. If the middle term is plus, then it's plus, plus. If the middle term is minus, it's minus, minus. All right. Now what's the third and final step? Verbalize.
Factor 8.
That does what?
It adds to 6.
Okay. What factors of 8 add to 6?
4 and 2.
There's your answer. And notice it doesn't matter. In this case, this is only 3 steps because I don't have to decide where the 4 goes and where the 2 goes. If it's a plus minus, then there's a 4th step where you have to put one number with one sign and the other number with the other.
Mm-hmm.
So this looked like a hard quadratic, but once we took out a greatest common factor, then it turns into an easy quadratic.
Mm-hmm.
All right, how about another one? Have you had the quadratic formula?
No.
Okay. If these first three fail, then you go to the quadratic formula. But I'll wait until they teach that to you before I get into it. So what else are they giving you at the moment?
I mean, that's just what we're working on. That's about it.
Just find another expression that they want you to factor.
Here's one, I guess. X squared minus 15x plus 50.
Okay. We're going to assume this can be factored since they haven't taught you the quadratic formula yet. So do this step by step.
Alright, so x, and then it would have to be both of them subtraction signs.
Okay, it's x and x. And that's important because sometimes it's x and 2x or x and 3x. So you need to do both, okay? And you're right. This tells you that signs are the same, and the minus on the middle term tells you they're both negative. What's the third step?
Find out the greatest common factor.
Huh? Well, you're close. Factors of 50 that do what?
Oh, sorry. That's add to 15.
What factors would that be?
5 and 10.
Okay. And there's your answer. So those are really easy if you just use those simple 3 steps. Okay, what else?
Let's
Give me your
6.
Toughest one.
6x squared plus 66x plus 60.
All right. The moment I see a quadratic at your level that has the number 6 in front of it, I know there's going to be a greatest common factor because they're not going to make you factor this without that yet. So take out the greatest common factor. What do we have?
Three?
What's the greatest common factor? You're looking at a bunch of them right now. Greatest common factor means the greatest number divided into all 3 terms.
6.
Okay. What's left?
So x squared plus 11x plus 10.
Keep going.
And then it would be x, and then there would be plus, and then it would be 10 and 1.
Okay, I want to talk to you that's correct. Okay, let's talk about factoring numbers. I said factor 64. How would you do it?
I would do like a...
Always start with 64 and 1.
Right.
No matter what number you're tackling.
And then I would do 2 and 32.
Well, can you cut that 64 in half?
Yeah.
Okay, it's 32, which means you have to double the 1. So there's 2 more factors. Can you cut 32 in half?
Yes.
Which means you got to double the 2. Can you cut 16 in half?
Yes.
Which means you got to double the 4. Now, let's see, am I missing any? I could cut it in half again, but then I have 4 and 16. I am missing one. How come I can't figure out what it is? Well, maybe I'm not missing any. Let's take a slightly more difficult one. Let's take this one. Factor 35. Can I cut 35 in half?
No.
Can I cut it in thirds?
No.
No. Can I cut it? If I can't cut it in half, I certainly can't cut it in fourths. So
Right.
the next thing to consider is, can I cut it in fifths?
Yes.
Okay, and that cuts it down to 7, which means I have to multiply that by 5. And those are the only two factors of 35. In other words, when you get a starting number that you can't cut in half, try cutting it by a third, and then try cutting it by a fifth, and then a seventh, and so forth and so on. And eventually you will find all factors of a given number. Okay, let's take 24. Here's actually a pretty good one to work with. What's the next factor of that?
2 and 12.
Next?
3 and 8.
Well, if you do it by the system that I'm doing it, where I'm cutting 12 in half each time, then that's the next set. Now, cut 3 in half, and there you get your 3 and your 8. But if you follow this methodology all the way down, where you just keep cutting stuff in half until you can't cut it in half anymore, and then you can cut it in thirds, do that, or fifths, or whatever. And you'll find all of the factors. And you have to go through both sides. Sometimes you'll find another set of factors by trying to cut this in half. Well, if I did that, that's not a new set of factors. That's the same set. So I haven't found a new set of factors. But sometimes you will. Okay? So that's the way to factor a number. And that is a big part of factoring a quadratic, is being able to factor that final number that you're looking at.
Mm-hmm.
Okay? Blake, that's the end of our half hour. Hopefully you've gotten a good idea of what my tutoring style is and how this works. I have recorded this, so I will send a recording of it to you just as soon as I get it processed. And then I will leave it to your parents to schedule forward if they want. They clearly have been on my website because they use my automatic scheduling software. And have a good evening, and I'll hopefully talk to you again.
All right, thank you.
To log out of GoToMeeting, you just need to click on the X in the upper right, and that'll disconnect. Okay?
Okay, thank you.
Bye-bye.